last class, we looked at uh, output command using print, that we can use print to print out something. Then we looked at casing system, where we looked at the Pascal casing, the camel casing, and the snake casing. And we emphasized on the snake casing, that's the convention in Python community. Afterwards, we looked at input. Input is used to get information from our users. Then we can save this input in a variable. So whatever the user inputs here, we are saving it in A. So today we are looking at data types in Python programming. Let's go. Now, what I'm going to do now is this. I'm going to collect a number from a user. Then I will add 5 to that number. Let's see what happens. No, normally, let's say I have 4 here. 4 plus 5. This should give us 9, right? Like this is going to give us 9. 4 plus 5 is 9. This is giving us 9. But let's see what happens when we get it from users. Let's say input num. Enter a number. If I say print num, it's going to print 5. Whatever number the user entered, it's going to print that for us. So let's assume I entered 6. Like this is going to give us 6 also. It has printed this 6. But what if we now have something like this? Whatever number the user entered, we are adding 5 to it and we are printing out the old results. Let's see what happens then. I will enter 6 again. But this time around we have an error. It's throwing an error. So the next thing should be, why is it like that? Normally 6 plus 5 is 11. And this should give us 11. Sorry, I want to use another terminal. This is covering my screen. We have this error. Why is it not good? I'm trying to. Can you see this terminal, sir?
Yes.
Okay. So from the other message, it's telling us type error. Can only concatenate string, not integer, to string. So let's explain what is going on. It's saying that what we have here is not a type that you can add 5 to. It's not something you can add 5 to. Now let me explain what is happening. If I say, can you give me the result of this, sir? If I say Taye plus 7, please, what's the results? It's not possible, right? Since Taye is not a number. Abi? So it's not possible. That's what is happening here. It's unable to add 5 to this because this is not a number. Now, wait. You might be like, we entered 6, which is a number. But Python is not seen as a number. In fact, it's seen it as a text like this. As a text, not as a number. And that's the reason it's unable to add 5 to it. Python can only add numbers together. But if one of them is not a number, it cannot add it. It's going to throw an error instead. Are you following, sir?
Yes.
Okay, sir. So how do we handle this? Or let's go deeper into these areas. There are what we call data types in Python. That is the types of data that we make use of in Python. We have integer. We have floats. We have boolean. We have string. Then, okay, we have some other data types aside this, but for now, these are just the 4 we're going to be looking at. Well, later, when we get close to the end of the program, we'll look at the remaining data types. We have integers. Integers are whole numbers. For instance, 2 is an integer. 9 is an integer. Integers are whole numbers. Then we have floats. Floats are decimal numbers. 2.5 is a float. 4.8 is a float. Then we have booleans. Booleans are either true or false. Booleans, they are either true or false. Anything aside this is not a boolean. Now let's now look at the last one. Okay, so let's now look at the last one, which is a string. But before then, I want us to experiment a bit on these three. And let's check out something. If I say print 5, it's going to print out 5 for us. 5 is an integer. If I say print 5.7, it's going to print 5.7 for us. 5.7 is a float, making the second one. Let's go to the third one. If I say print 2, it's going to print 2 for us. Right. If I say print false, it's going to print false for us. So we've looked at integer, we've looked at float, we've looked at boolean. But what if I now have print taye? This is going to throw an error for me. It's throwing an error. Now the error is this. Name error. It's telling me that this is a name error, that it doesn't understand taye. Taye is not defined. What happens is this. When you just write something like this in Python, Python will check. Is it a number? No. Okay. Is it a float? Like, is it a number? When I say number now, integer and floats, they are numbers. Is it a number? Whether it's an integer or a float. You say, okay, no, it's not a number. Okay. Is it a boolean? No, it's not a boolean. Next, if it's not those ones, then it assumes that it must be a variable. I come again. If it's not a number and it's not a boolean, then Python assumes that it must be a variable. So what happens is that after searching my codes, it's unable to see any variable named taye, and that's the reason for the error. After searching, it searched through my code looking for the variable named taye, and if there's no variable called taye, then it throws an error, and that's the reason for this error message. Taye is not defined. So what if I just want to print ordinary text? Like, I want to tell Python that this taye is not a variable, yet I want to print it out. I want to print ordinary text. What you do is this. Whenever you want Python to see things as text, you put it in quotes. Like this. Whatever, it can be single quote, it can be double quote. Whatever you put in quotes like this is seen as ordinary text. And a good example I love to use, or a good analogy, is English language. In English language, when you are reporting a speech, in the exact words of the speaker, you are telling the receiver that, see, I did not process this speech. I'm relaying it to you in the exact words of the first speaker. Then what do? We put it in quotes, saying that, see, I'm quoting it verbatim. Like, I'm not adding, removing, I'm not process, or I didn't process it. It's the same concept here. Whatever you put in quotes is seen the exact way it's written. No addition, no subtraction. It's seen just like that. Just like that. If I put a space here, when it prints it out, it will add this space also with it. Whatever I put here, it's going to be seen the exact way. And Python will not assume that this here is a variable. It's not going to assume. If there were no quote, it will assume that it must be a variable. Right? But if it's within quote, it's not going to see it as a variable. Instead, it sees it as text. Do you understand, sir?
Yes.
Alright, sir. So, whatever you put in quote like this is known as a string. String. Whatever is in quote is a string. So the implication of that is that this here is a string, not a number. It's a text. Say it like that. So I cannot, just the same way I cannot say Taye plus 5. Same way also I can't say I cannot do this. So let me close this and reopen. Just the same way I cannot say Taye plus 5. The same way I can say 27 plus 5. Sorry, I want to remove this. I'm coming. Please a second, please. I will close this VS Code and reopen it. Please, it has taken away my cursor. Good. The same way I cannot say Taye plus 5. I cannot say 27 like this plus 5 because this is not a number, but instead it is a text. And that brings us to this part. The data type of a variable tells Python how to process that variable. That means the way Python will process 6 plus 4 is different from the way it's going to process 6.0 plus 4. Because the first one was an integer, while this is a float. Integer is a data type, float is another data type. The data type of a variable tells Python how to process that variable. Now, how can you now check the data type of anything? If you want to check the data type of things, there is something we call type. It's an inbuilt function in Python. Type. If I want to see the type of 4, that is, tell me the data type of 4. Tell me the data type of 4. Let's print it. You know, whatever we do not print will not be displayed. So let's print it out. Print this. Let's only goes together. So we have class ints. Let's go to the next one. What if it's 4.0? We have class floats. Let's go to the next one. What if it is like this? Class string. So the data type of a variable tells Python how to process that variable. So, and if you want to check the data type, just say print the type of that value. Now, let's get a variable 7. I can say print type A. So tell me the data type of this variable A, and it's going to display integer for me. Any questions, sir?
It's okay.
So let's now go back to the where we started from. This is where we started from. What happens is this: whatever you get using an input, whatsoever you type using an input, whatever you get using an input, is always a string. Always. Whatever you get using an input is always a string. That means B, whatever I type and I save it to B is not a number, it's not a float, it's not an integer, it's not a boolean, it is always a string. Then if I say print B, this is printing that string for us. If I say print the type of B, that is print the data type of B for us, this is going to print string. Let's run it. Let's assume I entered the class str. It's telling me that the data type of B is 10. Let's print B itself out so that we can see that it holds 10. So B itself is 10, but data type of B is a string. And that is the reason I cannot say print. I cannot do this. Print B plus 1. This is going to throw an error because so this is going to print 10 for us, but you cannot do this one. B plus 1, this line 4 will throw an error for you because you cannot add string to a number. So the first line worked, second one worked, but when we want to add 1 to B, we have an error. So next is how then do we had maybe do we take values from users and maybe add things to it? How do we handle that part? That brings us to something we call typecasting. Typecasting is when you convert from one data type to another data type. You can convert from an integer to a string, from a string to a float, from float to an integer. Like, you can convert from one data type to another data type. So, let's convert an integer to a float. If I say a equals to 5, a is 5, right? If I say print a, this is going to print 5. But I can now say, instead of printing a, print the convert a to float before printing it. I'll just swap it with float. Float a. This part, a is still 5. In fact, a will still remain 5. But at this point of printing it, it's going to print the float version of a, which is going to be 5.0. 5.0. Do you understand, sir?
Yes.
Okay, sir. But our a is still 5. In fact, if you come here and say print a will still remain 5. But just that at this point of printing it on line 2, we are converting it to a float at that moment. So this is 5.0, but a is still 5. It would have been a different scenario if we had written it like this. Float a. Float a. This one, we convert this 5 to float and save it inside a. So what we have inside a right from beginning is 5.0 right from beginning. So we don't even need this line again. I can just easily say print a. This is going to give me 5.0 because what we saved inside a right from beginning is a float. So do you understand the difference, sir?
Yes.
Alright, sir. So we've seen how to convert from integer to float. We can also convert to string. Let's convert to a string. We can have, it might be like this. We can convert it to an integer. Print int a. So this part, we convert a to an integer. Well, when we check it, it's not going to make much difference. That is, if I go to the next line and I say print a, print a. This line and this line will give you the same thing, but really they are not the same. 6, 6. But you see, the first one is the first one is an integer, while the second one is a string. Even though they look the same, but the first one is an integer, while the second one is a string. If you want to confirm it, just wrap it with the type function. Just wrap with the type function like this. So this type will give you integer, while this type a will give you string. So the first one is an integer, while the second one is a string. So I can add something to the first one, but I cannot add something to the second one. I mean, I can say I cannot do this here. This second one will throw an error. Sorry, remove the type. This second one will throw an error. This first one will not. It will not. So I can say the first one is working fine, but the second one is throwing an error. So the summary is that you can convert from one data type to another. Just wrap it with whatever you want. I can also convert it here, which is something we're going to be doing often. We convert it right from this place. Int, like this. So what I'm saying is that convert this to an integer and save it inside a. So right from beginning, a will be an integer. It's not going to be a string again. Even though this 6 is a string, but because we are converting it to an integer before saving it inside a will always be an integer like that. So I can now conveniently do something like this. Print a plus 2. and this will give me 8. Let me clear this guy. So this gives me 8. Any questions so far, sir?
Okay, but what would make us to write the 6 in the string form? Why do we want to write the 6 in the string form and not just leave it as integer? Is there any reason why we will have to quote that 6?
Okay, sir. Thank you so much, sir. What a beautiful question. Now, that brings us to this part. Remember I said whatever you get using an input is always a string. That means if a user entered number, let's say the user entered 6, Python sees it as something like this, not as this. This is what Python sees. We may think like to how nice we see this, but this is what Python sees. So what you now want to do is this. You can now say, I know whatever the user entered will be seen as a string, so I want to convert it to an integer before saving it inside my variable. Do you get it, sir? So this is going to force it to be an integer before saving it inside the. We can now easily say print a plus 5. Let's sound the class together. Let's say the user entered 4. So this is giving us 9 because we've converted it into an integer before saving it in A. Do you understand, sir?
Yeah.
So if you convert it to a float, let's say the user entered 7. You can see the result is 12.0. Any questions, sir?
How were you able to open another terminal on a separate slide?
Okay, sir. Now, let's see. Let's go to the devices. This is a folder where I'm writing codes. I will open this folder. These are file where the codes where our codes are being written. I want to open this in terminal. Now the terminal here in VS Code, this is VS Code terminal. But another terminal came with our system, with Windows itself, like every operating system, we have an inbuilt terminal, and that's the one we are currently using. The one on Windows is known as command prompt. So we want to open it with command prompt. That one is even more powerful than the one in VS Code. So in order to open this folder in command prompt, just come to this top here. This is the folder is already opened here. So just come here, remove everything there, then type CMD, like Chief Medical Director, CMD. Then you press enter. When you press enter, it will open it in command prompt for us. Now we can now start typing our code, Python index.py, like this. And it will run the
When you want to go back to the other page, you just minimize.
You press Alt Tab. Alt Tab will open the last thing you like. It's going to open the last thing you closed. Right? Do you understand, sir? Like the last thing you open.
Okay.
So if
press Alt button and Tab button together.
Yes, sir. You can also press Alt. You can hold the Alt button if you want to navigate multiple pages. You hold the Alt button, then you now start pressing Tab one after the other. Tab. These are all those things that are opened on my device. So I'm pressing Tab to move it from one to the other.
Okay.
So this is going to add this together. Any questions, sir? So we've looked at some data types: integer, boolean, float, and string. Let's go to if statement, and that's where we are ending off today's session. If statement. If statements are things we do whenever we want to, okay, let me put it this way. Sometimes we want to execute some things based on some certain conditions. That is, if these conditions are met, then do these things for us. And maybe when they are not met, don't do anything. For instance, the reason we started this class this morning is because it was 8 a.m. Right? That is, we check the time. Is it 8 yet? It's not yet 8. Don't start class. Once it's 8, then start the class. So we are starting the class based on the condition that the time is 8. Check this condition. Is it 8 yet? If it's 8, start. If it's not yet 8, don't start. And that is what we do with if statements. We do things based on some certain condition. In fact, every day we run a lot of if statements. We run a lot of if statements. That is this thing so? If this condition is so, do this for me. If it's not so, don't do this. So that's what you also want to do with programming. If some conditions are met, you want to do something. If those conditions are not met, you're not doing anything. Or you want to do something else. Now, to write if statement, or we also call them conditional statements. Conditional statement. You start with if, the word if. That's the beginning of if statements. If. After writing if, you open a bracket in front of it. This bracket is not compulsory. That means whatever I want to do here, I can also write it here directly. The bracket is not compulsory, it's optional. You can put a bracket, you may choose not to put a bracket. So you open a parenthesis, but well, I like opening parentheses. You open a parenthesis in front of if like this. Then you put your condition here. You put your condition here. After your condition, you put a colon here. This colon is compulsory. Whether bracket is here or not, you must put this colon. Then you press enter. Whatever you want to do, you do it here. Do something. If this condition here is met, it's going to do whatever you have here. Do you understand, sir?
Yes.
If this condition is not met, it will not do this. Now, the location of this do something is very important. Notice this indentation. This space here, between this and beginning here. In Python, indentation is a big deal. That means if I remove this, it's not going to work. The indentation must be indented like this. And this indentation is from the beginning of your if, this word if, from the beginning of this if to this do something, there must be a tab, like just press tab once. Go to the beginning of if, then press tab. It is well indented now. Another thing you can do is that come to this colon, press enter. It's going to automatically take you there. Please, it must be tab, or you press space bar 4 times. The space bar, you press it 4 times. From the beginning of this if, 1, 2, 3, 4. If it is 3, it's not going to work. 1, 2, 3. This is going to throw an error. If it is 2, it's going to throw an error. If it is 1, it's going to throw an error. Do you get it, sir?
Yes.
But instead of using spacebar 4 times, just press tab once. That's better. Now, whatever you have outside of this place, another thing, I just said another thing, is not inside this if statement, meaning that whatever you have on this line 3 will be executed whether this condition is met or not, because it is not within the if statement. To know what we have inside the if statement, just look at this indentation. This do something is within this if statement, another thing is not within if statement. LO is within the if statement. That means if this condition is met, it's going to do this too. But if this condition is not met, it will not do this too. But it will always do this another thing, whether the condition is met or not. Any questions, sir?
It's okay.
Okay, sir. Let's take it. Let's now do that cuts. A is 4. We can say if A is greater than 2, print hello. If A is greater than 2, print hello. So will it print hello or not?
Yes, because A is greater than 2.
Exactly.
Or is greater than 2.
Exactly. Thank you, sir. So that's why we have this hello here. Let's move on. If it were to be 1, are we going to see hello or not?
No, because 1 is lesser.
Exactly. Thank you, sir. So that's why we can see anything. Let's move on. Friends, good morning. Now, if you run this, are we going to say good morning or not?
Yes, we are going to say good morning because it's not indented. It's not indented, so it's not part of the command for if.
Thank you, sir. Correct. Good. So you really got my explanation. Now here, you can put some conditions. You see this greater than is known as a comparison operator. We use it to compare values. So greater than is a comparison. Another one is the less than, which is another comparison operator. So far we've looked at 2 comparison operators. Greater than, less than. We've talked about commenting, have we?
Yes.
Okay, so let's comment this part out. Another comparison operator is a greater than or equal to. Let's look at that part. If A is greater than or equal to 2, print hello. Of course, 0 does not meet any of the 2 conditions. 0 is not greater than 2, and 0 is not equal to 2, so it will not print hello. The difference between the greater than or equal to is that in case the value of A is 2, for greater than or equal to, it will still print hello, even though exactly, because it's equal to, you get it right. So that's why we have hello, good morning. But if this were just to be greater than alone, it will not print hello. We also have the less than or equal to, just like greater than or equal to. Then another one that we have is the equal sign. Let's look at that part. Before we go into that, I want to quickly explain something that will make that part clear. A is 2. A is 4. Print A. What will this give me?
4. Because exactly. The last command.
Thank you, sir. 4 because it is the last command. This equal sign is the one that we're able to use to assign 4 to A. Like this equal sign is an assignment operator. Is used to assign a value to a variable. Now let's continue now. I want to check if the value of A is, let's say, 3. If A is equal to 3, print hello. Now if I come here and I say A is equal to 3, print hello, this is throwing an error. If you run this, it will throw an error for me. Whenever you see this red like this, it shows that something is wrong with the code. There's a syntax error somewhere. What happens is that what we want to do is not to change the value of A, right? You know, A equals to 3. This will change the value of A to 3. But we are not trying to change the value of A. We are only trying to compare, to check if A is 3. Do you understand, sir? So we are not trying to change the value of A. The equal sign is an assignment operator which is used to change the value of a variable or to set the value of a variable. But we are not trying to set the value of the variable. Instead, we are trying to compare the value of A with 3. And now see if A will still remain 2, right? But check if the value of A is 3. If it's 3, then do whatever we want to do. So this equal sign is an assignment operator and we cannot use it here. An assignment operator cannot be put here. What we put here is, that's why when we started, I wrote something like this condition. What we put here is a conditional statement, a comparison operator. That's what you use here. So if we have this is going to an L. Of course, we can assign. So what we have there is what is expected is a comparison operator, not an assignment operator. Do you get it, sir?
So if A is equal to, we cannot use equal sign for if. Is that correct?
Exactly. Yes, sir. We cannot use equal sign.
But we can use all the other comparative signs like equal to or greater than.
Yes,
greater than, less than others.
Yes, sir. So what if we now want to check if A is equal to 3? There's another syntax for that. We are leaving the double equal to do that for us. Because the single equal to is an assignment operator, which will not work here. So Python gave us the double equal to. If all we want to do is to compare, this will not change the value of A to 3. This will only check if the value of A is 3. Do you get it, sir?
Okay.
Alright. So when we check this now, when we run this will only print good morning, because of course 2 is not equal to 3. That's why we have good morning. But let's assume the value of A is 3. Then this will print
But
hello.
if you sorry.
Yes, sir.
If you remove print good morning, what will it give us?
This will only give us hello because the value of A is 3.
No, before you put, if this one is 2, yes.
It's not going to show us anything.
Okay, yes, because it's not, yes.
So that is for if. Any questions, sir? Let's now go to the if else. Else means in case this condition is not so, then come to the else part and do whatever you have there. If this condition is true, it will do this if part. If the condition is not so, then it's going to come to the else part and do this. If this condition is so, it will do the if part. If the condition is not so, it will do the else part. Before now, if the condition is not so, we are not doing anything. But now there is an else part. That is, if the condition is not so, then go to the else part and do what we have there. Do you understand, sir? Do you get it, sir? Hello, sir.
Hello, can you hear me?
Yes, I can hear you now.
Yes, I was asking a question that, does it mean that all these words that we are using, like else,
yes, sir,
if, type,
yes, sir,
we cannot use them as variable?
Exactly, yes, sir. We cannot use them.
They are used for a purpose.
Yes, sir. Exactly, yes, sir. Right.
Because it looks like they are identified for a particular thing.
Yes,
correct?
You got it right. You got it right. Thank you, sir. So if you can only do one, like with if you only want to do something, and if the condition is not met, you are not doing anything. But with if else, you can either do this or this. If the condition is met, it will do this. If the condition is not met, it will do this. So when we run this now, we are going to see how are you doing. Again, indentation is important. How are you doing? But let's assume the condition is met. Then we see error.
Hello.
Assignment.
Now, this S, sorry.
Okay, sir.
The S2 must have that column in front.
Yes, sir.
If A equal, you must put column.
Yes, sir.
So S2 must have column.
Exactly. Yes, sir. Now, here is it. The assignment is this. Tell the user to enter the time. The user can enter 1, 2, 3. You don't need to add AM or PM. Just to enter the time in form of a number. 1, 2, 3, 4, 5, 6, 7. Now, if the time entered, if it's before 12, you say good morning. You print out good morning. But if the time entered is 12 and above, once it's more than 12, you print enjoy the rest of your day, or enjoy the rest of your day, or something. So, if the time entered is, if it's lesser than 12, you print good morning. But if it's 12 and above, you display enjoy the rest of your day. Do you get it, sir?
Yes.
Yes, sir. Thank you so much, sir. Have a nice day, sir.
Thank you.